So in this type of problem, we have a different type of rational equation word problem. This one involves distance, rate, and time. In the other video, we talked about working together problems. In this case, we have a distance, a rate, and a time given to us. So we're going to use the formula D equals RT, which is something you should know from other classes. When you have distance equals rate times time, we can solve for any of the variables. So if we look at this problem, it's telling us that the plane is flying in the same time it takes the car to drive a certain amount. So with these types of problems, most likely we're going to have to solve for t. So let's get t by itself. So to get t by itself, we're going to divide both sides by r. So t is equal to d over r. Now we have two different modes of transportation. We have the plane and we have the car. So we're going to make each one its own fraction. So for the plane, we have the plane's time is going to be equal to its distance, and the plane flies 1,600 miles over its rate. Now, if we notice, we don't really have that much information about the rate of the plane. It tells us that the car travels 258 miles per hour slower than the plane, so that means the plane we're just going to call R for right now. Then we have the car. So the car is going to be the time of the car is going to equal its distance, which is 310 miles, over its rate, which is 258 miles an hour slower than the plane. So it's going to be r minus 258. So whatever the rate of the plane is, minus 258. Since we know they travel in the same time, we can set these two equations equal to each other, since they both are equal to t. So what we're going to do is 1,600 over r, and that's going to be equal to 310 over r minus 258. Now, we can do this one of two ways. We can try to get that common denominator and multiply out by the common denominator. Because these are two fractions, there's one fraction equal to another fraction, I think it would be easier to cross multiply. So that's what I'm going to do. But you can solve it different ways. So if I cross multiply this, I'm going to do 1,600 times r minus 258. And I'm going to set this equal to 310 times r. So 310 r. So now I'm going to distribute the 1,600 to both. So I'm going to have 1,600 r minus 412,800. And I'm going to make this equal to 310 r. So now we want to get like terms on the same side, so we can subtract the 1,600r, bring it over to the other side, over here. So that's gone. Bring it to this side. So now 310 minus 1,600. So we have negative 412,800 equals negative 1,290r. So now we want to solve for r. So we're going to divide both sides by negative 1,290. And then we end up with r, which is equal to 320. And it's, again, a word problem. We want to make sure we have the right units. It's rate, so it's going to be miles per hour. So now if we look at this problem, Manny rides his road bike 3 miles an hour faster than Veronica. If Manny travels 45 miles in the same time Veronica travels 36 miles, how fast is each riding? So again, we have distance, we have rate, and we have time. So again, we're going to remember that distance is equal to rate times time. So we're going to solve it for time again and say that time is equal to distance over rate. Okay, so we have two people. We have Manny and we have Veronica. So there are two fractions we have to set up. And there are two different ways you can do it. So for Manny, we need his time formula. So time is equal to his distance. So he travels 45 miles. And so his rate, well, he rides his bike 3 miles an hour faster than Veronica. So we can decide who should be R, if Manny should be R or if Veronica should be R. It doesn't matter as long as you make the other person's speed in relation to what you made R. So for instance, if I want Manny to be R, okay, let's just put him for R right now. Veronica, her time equation is going to be her distance, which is 36, okay, and her rate. Well, if Manny's R and Manny is 3 miles an hour faster than Veronica, that means that Veronica would be R minus 3. So if Manny was 10 miles an hour, Veronica would be 7 miles an hour. So she's 3 slower than Manny. If you wanted to think of it the other way, so I will write this in purple, and you wanted Manny to be not the R, if you wanted Victoria to be the R. So if we want Victoria to be R, which is fine, and Manny's 3 miles an hour faster than Veronica, he's going to be R plus 3. Okay, so it does not matter if you choose to do it in the blue way or in the purple way, as long as it makes sense. As long as if you pick a value for R, any number, and you plug it in, as long as Manny is more than Veronica, however you want to set it up is fine. I'm going to do it the blue way, because that is the way that I did it, but either way will give you the same answer. So again, because it's in the same time, we're going to set them equal to each other. So I'm going to take 45 over R, which is Manny, and set that equal to 36 over R minus 3. Okay, and then again, similar to the other problem, you can choose to either get that common denominator or cross multiply. Okay, I would cross multiply, I think that's easier. So I would do 45 times R minus 3 and make that equal to 36R. So then I would distribute the 45. So 45R minus 135 equals 36R. Okay, and then I would take the 45 and bring it to the other side. So I'm going to minus 45R, 45R. So then I have negative 135 is equal to negative 9R. And then I can divide both sides by negative 9. So then we end up with R is equal to 15, and it's miles per hour. Miles per hour. And then the question is asking us for how fast is each riding. So this is where we had to just pay attention to what we made our variables. So since R is Manny, I know that Manny is riding for 15 miles per hour. And then Veronica is R minus 3. So since she's R minus 3, I'm going to do 15 minus 3. So Veronica is traveling 12 miles per hour. Now, if you did it the purple way, which is totally fine, when you solve for R, you would end up getting 12 because R is, in this case, Veronica. And then when you plug it into Manny, R plus 3 would be 15. So regardless of which way you do it, you will end up with the same two answers, 15 and 12, making sure that you know whose is whose. This last problem is a little bit different than the other ones. So today you ride your bike to a store 4 miles away to pick up things for dinner. You ride your bike west to the store and east home. The round trip takes 1 hour. When riding west, the wind decreases your speed, and when riding east, the wind increases your speed. If you ride at 10 miles per hour with no wind, what was the speed of the wind today? So this is different because it's not asking us for something happening at the same time. So instead of having our time equal to each other, we have a total time. So we're still going to use the idea of distance equals rate times time. And we still want to focus on time. So I'm still going to solve this for t and say that t is equal to distance over rate. Now the difference here is that there's not two different things where the time is going to be the same. Because the wind is speeding you up one way and slowing you down another way, the time to the store and back will not be the same. So there's really two different times. So we're going to say that the time one way, so the time to the store, so we'll say T1 plus T2 is going to be equal to the total time, which it tells us it's 1 hour. So we have two different ways we're going. So to the store, we're going west. So to the store, the time is going to be our distance, which it's 4 miles to the store. So both to the store and back home, it's going to be 4 miles. So it's 4 miles. And then the rate, so since we're going to the store and the store is west, it says when riding west, the wind decreases your speed. So we don't know what our speed is with the wind, but we do know without the wind, our speed is 10. So if we're traveling 10 miles per hour, but now the wind is hurting us, the wind is decreasing our speed, we don't know what the speed of the wind is, so we're going to minus x. So whatever that speed of the wind is, we're taking that away from our 10 miles an hour. So we're actually going less than 10 miles an hour to the store. Now, from the store, which is going east, so we're going the other way, so from store, we're going to have the same type of idea. So the time from the store back home, we're going east this time. It's still going to be 4 miles from the store to home. But now going east, the wind increases our speed. So we're still traveling 10 miles an hour without the wind, but the wind's going to help us out, and it's going to increase our speed by the speed of the wind. So we're going to be traveling faster than 10 going home. So we're not going to set these equal to each other because they're not the same. We're going to use this idea of time 1 plus time 2 is equal to 1. So here's time 1, here's time 2. So 4 over 10 minus x plus 4 over 10 plus x is equal to 1. Now, we want to get a common denominator. So in this case, it would be 10 minus x and 10 plus x. So we're going to multiply everything by that common denominator, which is 10 minus x, 10 plus x. So we would multiply 10 minus x, 10 plus x to the first fraction. 10 minus x will cancel out. So we're going to have 4 times 10 plus x. And then same thing here, we're going to do 10 minus x's are going to cancel. So we're going to have 4 and 10 minus x. And then this one is missing both of them. So if I multiply them both together, I'm going to get 100 minus x squared. So now I can just distribute everything. So 4 times 10 plus x. So I'm going to get 40 plus 4x. And then distribute the other 4. So I'm going to get plus 40 minus 4x equals 100 minus x squared. And then we can just move everything and solve for x. And we end up getting that x is equal to 4.47. miles per hour for the wind.